Alrighty, hi everybody. So today we're going to be doing an electrical engineering problem with BJTs. So with that being said, here we're given these transistors with these beta values. And so we need to find the emitter current of Q2. So what's the current going on right here? So we need to find that, and there's two ways that should come to your mind when you're trying to find emitter current. Here we have IE2 equals alpha IC2, and IE2 equals IC2 plus IB2. However, although we will be using these types of equations, we're not going to be using that to solve for I2 specifically. Instead, for IE2, we notice that it's saved, it's conserved. Everything here is conserved. So right here we have IE1. Sorry about it being a little messy. But here we have IE1 and here is IE2. And you'll notice that this entire thing just goes to ground. It doesn't really go anywhere else. So current is conserved. And so IE1, in this case, we can equate that to IE2. So now we want to find IE1. And the way we're going to do that is through these types of equations. So, with that being said, the first thing we want to do immediately when you see this, what do? Thevenin. So we are going to redraw the circuit. Okay. And then here, that's going to give us 5.76K. Oh, goodness. And this is just simply the parallel of 9K and 16K. And then up here, we're going to get 1.5, which is from 16 over 9 plus 16 times 2.5, which is the voltage source up there. All right. Great. And then the rest of the stuff is just down there. Okay, now we can actually do something with this. So we'll notice that we can set up KVL. I'm going to redraw the other parts. Let's do that real quick. Zoom out. Okay. Excuse my slightly messy drawing. Okay. I'll label this Q2. Okay. Cool beans. So now we're just simply trying to find the current right here. And what we can do next is set up a KCL. So what we're going to do is, I'm sorry, this is actually supposed to be 1.6. Okay, so to set the KCL, actually I'm going to do this in green. We're going to do, okay, we're going to do 5.76 IB plus 1.6, that's from here, minus 0.7 minus 0.7 equals 0. Now, where are we getting these from? We're getting them from right here. So all of this should take us to ground. And this is going to give us negative, oh, I'm sorry, this should be negative 0.2, and we'll get IB is 34.7 microamps. Great. Now we're getting somewhere. And look, if we go back up here, we're already halfway done with that. Also, it's worth mentioning, every time they give you a beta, chances are you're going to be using it to find the collector current or the base current. Almost always, it's going to be boiled down to that. So we can do that. So we have IC1 equals IB1, well, that's just IB, times beta. They gave us beta to be 100. So we get IC1 equals 100 times that, which is just going to be, I believe, 3.47 milliamps. And this is usually like in the normal range we get for a collector current, and this is also the normal range for a base current. Alright, now we can use this right here, a summation of currents, to get the emitter current. So we have IE1 equals IC1 plus IB1. And this is going to end up in 3.505 milliamps. And like we said, IE2 is equal to IE1. So this is just going to be that. And that is the solution. Alright, thank you for watching. I'll see you guys next time.